Hello. So this is our multiple linear regression question. Through this, I'm going to explain the everything of this, which is most important for all the people who are doing some data analytic study or using Excel data analytic tool to explain the regression equations. So here is our data. This sheet you have already received. Okay. Here I had the question also I have given. Here is the question which I have answered over here. This is the question over here. This is about a car. Output is influenced by several factors. One of them is its maximum speed, another is the displacement covered. And then you have to answer these questions like state the multiple regression equation, interpret the meaning of the slopes B1 and B2 in this problem, explain why the regression coefficient B0 has no practical meanings, and then you have to predict for a particular value of maximum speed and the displacement, the power output. And then you have to make a confidence interval, then you have to make a prediction interval, and then you have to justify the significance of the regression model through the p-value, and then you have to interpret the meaning of r square and adjusted r square. So these are the questions that I'm supposed to answer based on this data given to me. Data given to me. Okay, and I have already applied that data analytic tool to get some of the answers over here, data over here. So how I got this data, I will just show you here in the another sheet. I have already copied. I have already copied the data. Here will be one of them will be the y, another will be x1 and x2. You may not write y or x1 and x2. You can write y as power and the x1 as maximum speed and displacement as x2 as the displacement. You may keep the same name. It doesn't make a difference. Okay. So what I'm trying to show now is how I will get the regression equation with the help of this data by using the data analytic tool. So I will go first here, the data, and then I will choose here data analytic tool. And in it, I will scroll down to see here the regression. Once I got regression, I click it, then it wants me to put some informations. So the first one is where you will put input y range. So I will click this one and select from the label the y value. I selected, I see here in the A column, it will start from 1 to 91. That means no data is missing over here. I have selected all of them. Next, I will be putting input X range. So I will be selecting both the independent variable here, which are maximum speed and the displacement. So I selected them, and I also see here it is 1 to 91, so nothing is missing. So I check this. Now next I will check here the label, because I'm using label, and confidence interval is 95%. Okay. Now the output range I will have to select. So I will be selecting the output range. And this I'm going to select here, but here I'm adding these two check. Okay. These three here checking. I will explain this. So not all the questions contain the involvement of these things, but I'm just checking it out. I will explain you over here. If it comes, then you will be able to answer these questions as well. So let me check now here where I will get my data. So here it is where I am selecting to have this data. Okay. So I selected this, and then now I have done all of these. So I remind here, first I will check the input y, then the both of x1, then I will check the level, then I will choose the output range, and these three residual residual plots and the nominal probability plots. So sometimes they ask in the question, so I have you just check them, it will automatically come out over here. So I click this, okay, and I got this data and these diagrams already you have, okay. So let me, now these are the data. Based on this, I will answer all the questions over here. So let me describe this. We have first this region here, summary output, where these information is about the regression statistics. Then we have here ANOVA, where we have regression models, probability here, residual and degree of freedom over here. And then we have the third one, where we are going to have the value of B0, B1, and B2 to have our multiple regression equations. So I will highlight these ones because I'm going to use them. So I highlight this one here. And I highlight this, which I will use. So I highlighted this. And I will highlight here this one. Okay. Look, see here carefully. I didn't put x1 and x1 and x2. So this one is my x1 maximum speed, and this is my x2. So naturally, this is going to be my b0. This is my b0, and this is my b1, and this is my b2. Now I'm in a position to write down or answer the question A, which asks me to write down the regression equation. So I will be writing here the regression equation, the general regression equation. I have already shown you here in this sheet, okay? In this sheet, you can see here the equations are already here. To save the time, I will just try to copy this over here. So here is my, so I have got, this is the general equation, y equal to b0 plus b1 multiplied by maximum speed plus b2 multiplied by displacement. This is x1, this is x2. And choosing the value that is already here, b0 and b1, the equation will be like this. You already you have this sheet, so you can check out over there, but I'm just showing you what was the answer so that you can understand better. So this is the answer of A. This is the answer of A. This is the answer of A. What is the regression equation? This is my regression equation. So I have already here answered the question number 1. I have answered the question number 1 here. Next is interpret the meaning of slope B1 and B2. So here answer already, you already have this sheet with you. I will be just reading it out and leave it for you because it's already over here. So as I explained you in the class, okay, here is the meaning of B1. B1 meaning what? B1 represent the amount by which the average power, the Y value, is increased by for 1 unit change in the maximum speed, the x1 variable, a speed keeping the displacement unchanged. So this is the interpretation of the B1, and similarly the interpretation of B2 will be, it is the amount by which the average power output is increased by when there is 1 unit change in the displacement, keeping the maximum speed unchanged. So this is the answer of the question from where I am asking you to interpret the So I have already given over here. I'm not copying this answer. You can easily go through this one. So we have already answered the question B. The question C is asking to the relevance of the B0. So a question is like this: explain why the regression coefficient B0 has no practical meaning in this context. Okay, so here is the answer for that. B0 has no practical value because it is negative in this case. So if you write this, the answer of the question C is done. This is enough to write, not to indulge too much of writing over here. So this is enough. And this sheet already you have these answers. So answer of the question C is done over here. Next question is predict the mean power output of car that have a displacement 1800 and the maximum speed 200 km/h. So this is given, and that one I will show you here in the new sheet. Okay, so here I will be showing you here. I want the y value. For me, I have the maximum speed to be given. Then I will have here maximum speed. Next, I have the displacement. And this is given to you 200. And this is given to you here 1800. And I will be now here doing equal to, then I will check the B0 value plus the B1 value, which is this, multiplied by the maximum speed, which is this one, plus the B2 value, which is this one, multiplied by the displacement value, which is this. And I got the prediction. So this is the answer of question number D here. Question number D, which has already been shown you here in the second sheet. I have also copied the sheet that I gave you. Here you can see the three sheets. Okay, sheet 1, sheet 2. In the sheet 2, you have the answer for the D. Okay, so I have already explained over here. You already have the sheet. You can check it out. So answer of the question number D is that the predicted value is 101.1399. So this is done. Now I will be going back to my question, that confidence interval question. The confidence interval question is here. They ask me here, construct a 95% confidence interval estimate for the mean power for cars that have displacement this. So we are going to find a confidence interval for the y value that we have already obtained. And let us do over here. What I will require here more with this, I'm going to show you here. I will need here T stat. I will need here the standard error. I will need here the square root of the number of observation, square root n. These things I will find it out. We already have here information how I will do this one. So for finding the T stat, notice this one, this is important. I will put here equal to, I'm using Excel sheet command. So I will put here T inverse. And then I will open bracket. I did what? T inverse. Then I open the bracket. Is asking the probability because our given 95%. So the probability over here is 0.05 and comma degree of freedom, which I have already highlighted here, this one. Degree of freedom for residual 87. So I check this and I close the bracket and I got my T-stat. Standard error is already available to me here, standard error. So I will be checking this out. I put equal to and I check this, I will get the value over there. So I get the value over here. Square root n, I will use the Excel command, square root, and then I will open bracket. And this is my n. This is my n, the number of observation. So I will select this and I got this one. So I have already got these informations. Okay, Mark, what formula I will be using over here is this formula I am going to use over here. The formula is that y, predicted y minus t stat multiplied by standard error and divided by square root of n. Here is a minus for the lower and the plus is for the upper. So this formula I'm going to use over here and let's see this. So I'm going to use over here. So for me, the lower value, this is our confidence interval lower value. So I have written lower, I put equal to, I select the y value, which is this. Then I put minus, I select the T-stat multiplied by standard error divided by square root n, and I entered. I got my lower boundary for the confidence interval. Then I will be doing the upper boundary. So I will be using the formula only, there will be plus. So equal to, then I will choose the y value. Then here plus, then I choose the T-stat multiplied by the standard error divided by square root n, and I got this is my confidence interval, okay? This is my confidence interval, okay? Sorry. Confidence interval. I have already shown this to you here. So I have already shown you this here. These answers are already here in the sheet that I provided you. Look here, the confidence interval is already over here, okay? But I'm just showing you because it needs you to know how to do it. So I have already written the answer here. Confidence interval is 95.88 and 106.39, which is same as here. So you will be getting these answers, okay? Let's go to find me. Let's go to find the don't be just worry about the values over here because here I might have taken some less number of points over here is saying 95.58826, which is same as little difference will not make same. I have not extended to see you all the values. Okay, so it's like this, don't confuse. Now I will be finding the lower bound for the second question, okay, where I want the prediction interval for this y, which I have already calculated, and I will be starting, and I will be using this formula, which is here. Predicted y minus t stat multiplied by standard error. I will not divide by square root n. So this is here, it will go like this. The y value minus the t stat multiplied by the standard error and this is my value. And then I will put for the upper bound equal to the y value and the plus. I will choose the t stat multiplied by the standard error, and I got this answer. This is my prediction interval. Okay, so we have done the answer to these questions. We have done the answer to these questions, E and F. Now I will be explaining the p-value. P-value here, I have already explained you this, okay? The p-value of the model suggests that there is a significant relation between the independent and the dependent variable because the p-value is less than 0.05. Look where from I'm getting this information. Look here in the regression model, unwise regression model, this value is almost 0. How you will get this? If you go there and put here the number, you will get the value 0, which is obviously less than 0.05. So if this is less than 0.05, from testing of hypothesis, I can confirm that this model is significant model where the independent variables and the dependent variables are highly correlated, which is available from this data. This is our correlation, okay? This is our correlation, which is 91.56. And the value, the highest correlation lies between, positive correlation lies between -1 to 1. So negatively, highly negatively, it would be -1. Highly, absolutely correlated, then it will be 1. So closer the value of 1, the most highly correlated. So this is, the model is confirmed by this probability. So answer of the question that use the p-value and interpret this. This is the interpretation of that is already shown on you over here. So this is the answer of question number, and I have also written over here the p-value of this model already explained over here. You can copy and read over here. So this is the answer of the this question. This is the answer of this question here. Determine the p-value in E, okay? So this is already done. Now we have to only explain the R squared, interpretation of R squared. I have already interpreted this one over here. Look, I have interpreted here R squared. Now this R squared is in percentage is 83.8. What does this R squared indicate in this modeling? So here is what I have written. This states that the 83.8% of the dependent variable, the independent variable that I will get for each of the entries, okay? So 83.8% of them is variable is explained by the independent variables, which is maximum speed and the displacement. So this is indicating the significance of this model and this regression equations. This regression equation is highly significant because the y values for each x1 and x2, what we will get out of 100%, it is 83.83% is explained by these independent variables. So this indicates that this is the important information regarding this regression model. Now, sometimes what happens, not all the values, all the independent variables where independent variables are really correlated. So we need to adjust this one. So in this case, if we go to see that adjustment R square is almost same. So the adjustment requirement is minimum over here. We are not supposed, so adjustment square, if there were difference means this will be the actual R square to be used to make a perfect regression equation. But here you see the 83.8, this also, this is 83.45, almost closer value, okay? And also it can be understood by this information. Look here. Look this one. The p-value, all of these over here are 0. This is also suggesting for each parameter over here how much significant is this. I can use t-stat, but it is easy to use the p-value. So p-value, if I do over here, like the one I did, this is here. This is also 0. This is also 0. This is also 0. I can show you over here this value. This value, look here, I show you here. This is 0. This is also 0, which all of them is less than 0.05. So this, the hypothesis that there is no correlation is rejected here. So they are highly correlated. So from here also we are getting the information about the significant connection between the independent variable and the dependent variable. So these are the questions that I have done. But in some of the question you might get here. Look this one. This is the residual versus maximum speed for independent. For each one, x1 is shown here. Residual versus this one, and this one represent the normality. This one represent that the normality is proven by this diagram. So here you can simply explain this one, that based on the residual analysis, the errors appear to be normally distributed. And this is very important property for the betterment of this or significance of this regression equations. So that the equal variable assumption does not appear to have been violated here. So this is these graphs are representing about the normality of the error, normal distribution of the error, and residual versus the maximum speed they want. It is already shown here, and residual versus displacement is already shown here. So if this question comes, you will be able to just put it down, and that will be enough for you to answer that question. So here is in this way we have already finished all the questions. So what you will refer is the one which I have already given you, this one, okay, and this video, follow it. Hopefully you will be able to answer this question, but actually these are the real information and idea that when you are going to use data analytic tool for prediction in business. So this is all about this question, and hopefully you have understood this. If there be now I will be closing this over here, but before that I stop recording.